we're tackling hydrostatic pressure on submerged surfaces, a key topic in the fluid mechanics section of the FE Civil exam. The fundamental concept starts with the pressure at a certain depth, which is given as pressure equals the specific weight of the fluid, gamma, times the vertical depth, h. This is a gauge pressure and it increases linearly with depth. You'll find this in the Fluid Mechanics chapter of your NCEES FE Reference Handbook. Now, the exam won't just ask for pressure. It will ask for the resultant force on a submerged surface, like a gate or a wall. For a flat submerged surface, the resultant force F is the pressure at the centroid of the area multiplied by the area itself. The formula is F equals gamma times h sub c times A, where h sub c is the vertical depth from the fluid surface to the centroid of the submerged area A. A common mistake is to confuse this with the total depth. Be careful. It's always to the centroid of the area in question. The next critical piece is where this force acts. It does not act at the centroid. It acts at a point called the center of pressure, which is always below the centroid. This is a huge trap on the exam. The location of the center of pressure along the incline of the surface, y sub p, is found by the formula. Y sub p equals y sub c plus the moment of inertia about the centroid, I sub c, divided by the product of y sub c and area A. Here's the most common exam trap. Y sub c is the inclined distance from the fluid surface to the centroid, while h sub c is the vertical distance. They are related by h sub c equals y sub c times the sine of the angle of inclination. The exam will absolutely test your ability to distinguish between these two. For example, consider a rectangular gate, 4 meters high and 2 meters wide, inclined at 30 degrees, with its top edge 5 meters below the water surface. First, you'd find the centroid's inclined distance, y sub c, which would be 5 meters plus half the gate's height along the incline. So 5 plus 2, which is 7 meters. Then, you'd find the vertical depth, h sub c, as 7 times sine of 30 degrees, or 3.5 meters. The resultant force would be the specific weight of water times 3.5 meters times the area of 8 square meters. To find where that force acts, you'd calculate the moment of inertia for the rectangle from the handbook's table, which is base times height cubed, divided by 12, and plug it into the center of pressure formula. For curved surfaces, the approach changes. You resolve the total force into horizontal and vertical components. The horizontal component is simply the resultant force on the vertical projection of the curved surface. The vertical component is equal to the weight of the fluid volume directly above the curved surface. For a mnemonic, remember this: force is at the centroid's depth, but it pushes from below. This will help you recall that the force calculation uses the centroid's vertical depth, but the point of application, the center of pressure, is always deeper than the centroid. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.